In this lesson, I'll show you how to find the complete solution of a second-order differential equation. The question reads, solve y double prime minus 4 times y prime plus 4y is equal to e to the power of 2x. To do this question, I've outlined 7 steps. Starting with step number 1, what we have to do is find the complementary function y subscript c by solving the auxiliary equation. So what I'll do is convert the left side of this equation as a quadratic, where y double prime becomes m squared, minus 4y becomes minus 4m, and plus 4y becomes plus 4, and we set this equal to 0. We factor this, and that's really easy to do. What two numbers multiply to positive 4 and add to negative 4? That's negative 2 and negative 2. So we have m minus 2, m minus 2 is equal to 0. Therefore, our m is equal to 2. Once we've obtained our m value, we can write our complementary function, starting with y subscript c is equal to c1 times e to the power of our m, which is 2, times x, plus c subscript 2 times e to the power of 2x, that represents our m, times x. Notice that both of our roots, which we represented as m, were the same. To differentiate between the first and the second term, we multiply the second term by x, and if you've watched some previous videos, this concept isn't new to us. Step number 1 is accomplished. Let's move on to step 2. In step number 2, we have to write the particular integral y subscript p. And according to this, it should contain each term from the right side. In our case, we only have one term on the right side, as well as the first and higher derivatives of each term of f at x, minus their coefficients. So we're not going to include their coefficients or duplicates of the terms. Here's what I mean. Y subscript p is equal to the term on the right side, which is e to the power of 2x. I'll take the derivative of this equation, where I get y prime sub p is equal to e to the power of 2x, and we'll take the derivative of 2x, where it becomes 2. If I take the second derivative, I get y double prime sub p is equal to 4 times e to the power of 2x. Notice that this part continues to repeat. And since we're not regarding the coefficients, the 2 here and the 4, that means we should stop, because everything else after this will just be duplicates. Step number 2 is done. Let's move on to step number 3. If a term in y sub p is a duplicate of one in y sub c, multiply that term in y sub p by x to the power of n, using the lowest n that eliminates that duplication and any new duplication with other terms in y sub p. So what I mean by that is, let's consider e to the power of 2x. Take a look at y sub c. In y sub c, we have two terms. The first term, c sub 1 e to the power of 2x, is a duplicate. So according to step number 3, we have to multiply y sub p, which we chose to be e to the power of 2x. All of these we don't count because they're all duplicates. We have to multiply this by x. So if I multiply this by x, you'll notice that now it matches this. This term has e to the power of 2x times x. So instead, we have to multiply it by another x. Now we have y sub p e to the power of 2x times x to the power of 2. Here, x to the power of 2 e to the power of 2x does not duplicate any terms in y sub c, nor does it duplicate any terms in y sub p. So we can proceed on to the next step. In step number 4, we're asked to write y sub p. Now, since we only had one term in y sub p, we have to write it out with a coefficient a. So y sub p, a times what we found, e to the power of 2x times x to the power of 2. And had there been any other non-duplicate terms, they would also get an undetermined coefficient. This step is accomplished. Now on to the next. According to this, we have to substitute y sub p and its first and second derivative into the differential equation. So our differential equation looked like this. I'll substitute this into here, the first derivative of this into there, and the second derivative of this equation into there. So let's find the first derivative. We'll need to use the product rule. So we have y sub p, and that has a prime, a e to the power of 2x, we take the derivative of x to the power of 2, it's 2x, plus a, now we take the derivative of e to the power of 2x, which is 2 times e to the power of 2x, and we leave x to the power of 2 the way it is. So this will be brought into here. And to find the second derivative, we have to do the product rule twice, to this term and to this term. If you do this correctly, you should end up with the following equation. Y double prime sub p is equal to, therefore our equation on the left side here has become this minus 4 times this plus 4 times this. And if you set it up correctly, you should end up with the following. And there it is. I've highlighted everything that I've inserted. So all my y double prime sub p are in yellow. The teal highlight is y prime sub p, and this green one is yp. This step is done. Let's move on to the next step. We have to evaluate the coefficients by the method of undetermined coefficients. This term, and this term are all alike because they all have e to the power of 2x times x to the power of 2. These next two terms are alike. Notice that they both have x times e to the power of 2x. And this term and this term are alike. So let's start with the browns. We have 4a, and I'm going to disregard this factor because all three of these terms have that factor. So I have 4a minus 8 times a, coming from here, and plus 4a. This is equal to 0. The left side and the right side is equal to 0, so we can't retrieve any useful information there. Now the orange. We have 8a minus 8a, and that is equal to 0. The left side and the right side is equal to 0. No information there. Now on to the blues. We have 2a is equal to, and over here this becomes a 1 because of the coefficient 1. Therefore a is equal to half. This step is done. Now on to the last step where we combine y sub c and yp. That's the easy part. Y sub c looked like this. So we have y is equal to c sub 1 times e to the power of 2x plus c sub 2 e to the power of 2x times x. And now y sub p is half, which is what we just found, times x to the power of 2 e to the power of 2x. And there you have it. That is how to find the complete solution of a second order differential equation that contains duplicate terms in the solution.